Let's do example 1 on impulse. Dancers have to learn many skills, including how to land correctly. A dancer of mass 50 kgs leaps into the air and lands feet first on the ground. She lands on the ground with a velocity of 5 meters per second. As she lands, she bends her knees and comes to a complete stop in 0.2 seconds. Right. A. Calculate the momentum with which the dancer reaches the ground. B. Define the term impulse. This is just definition. We have to remember our definitions. And then calculate the magnitude of the net force acting on the dancer as she lands. Right. So now we need our information. So we have the mass of the dancer, which is 50 kgs. We have the velocity of the dancer, which is 5 meters per second. And then we have the time when the net force is exerted, 0.2 seconds. So this is information that we have. Now, A, calculate the momentum with which the dancer reaches the ground. So calculating momentum, remember momentum is equal to mass times velocity. And then we have the mass, we have the velocity. So momentum is equal to 50 times 5. But we need to choose our direction. Let's not forget the direction. So positive direction, let's say upwards. If positive direction is upwards, then the velocity is going to be -5 because she lands on the ground with a velocity of 5 meters per second. So this one is going downwards. So it means here is going to be negative if our positive direction is upwards. So it becomes mass, which is 50, and then -5 there. And then 50 times -5, that is -250 kilograms meters per second. That is what? Upwards, meaning that our momentum is 250 kilograms meters per second downwards. B, we're required to define impulse. That is B. We have to remember that impulse is a product of the net force and the time. And then let's put it in words. Impulse. So impulse is the product of what? Of the net force acting on the object and the time the net force acts on the object. Remember the definition there. And then C, calculate the magnitude of the net force acting on the dancer as she lands. We're going to use this formula. Delta P is equal to F net times delta T. Okay, and then we manage to get our momentum here. So our change in momentum, remember this is not momentum, this is change in momentum. So the change in momentum is 250, right? 250 kilograms meters per second, because it's changing from 250 to 0. It says that she bends her knees and comes to a complete stop. So meaning that a final velocity is 0, and then the momentum there, the final momentum is going to be 0. So the magnitude of the change in momentum is what? Is 250. Okay, so which is equal to F net, then delta T, which is 0.2 seconds, right? Then divide by 0.2 on both sides of the equation. We get that F net is equal to 1250 newtons.